My talk will be devoted to how to make the computers understand court verdicts. The problem is that in the legal services, the understanding is the most important thing, to find the law that is connected to our case, to find the court verdicts that are connected to our case. The problem is that the legal databases, the amount of data that we have in the legal area, it's very vast, and it's very hard to search it correctly. And the company that I co-established aim at delivering most intelligent legal research tools for the Polish law. Basically, we thought that there is no predictive features, no visualization, and it's very hard to navigate. And today I will show how we try to solve the problem, how hard it is to navigate in the legal domain, how hard it is to search the information, and how it could be solved. And it's co-founded by Maciej Troć. The company was co-founded by Maciej Troć from Faculty of Law and Administration of Warsaw University, and myself. I'm working at National Center for Nuclear Research in Warsaw. So, basically, the Polish law is vast and complex. If we would like to keep up with the law, we should devote it about 4 hours each day to read the law that is passed through the parliament, and this is only the main regulation, not the regulation that is passed in Warsaw or in Krakow and stuff like that. So the amount of data is enormous, and this is only a plain text. And on the other hand, the court verdicts that are publicly available, so for example, the Ministry of Justice of Poland make a portal with the court verdicts, but it's extremely hard to navigate. It's extremely hard to find the case that you are looking for unless you know what is the signature. But even though not all the court verdicts are here. And the other stuff that if we can of course use the tools that are publicly available by the main legal information providers, but usually I think they stopped from my analysis on the keyword search part. So basically it's a problem. The other stuff I would like to point you out why is the problem in the legal domain. Here is the amount of acts that is passed every year from the beginning of the Second Polish Republic and now. So here is the spike just before joining European Union, but it does not get any better. In fact, it stops somewhere around 2,000 acts passed by the parliament. And of course, in the Second Polish Republic, the law was quite well separated. This is a graph of connection between the acts that were passed in the parliament. You can say for the railways, industry, country governance, and stuff like that. And if we go to our times, this is the value-added tax, how we can show it on the graph, how connections work out. And this is, well, it's complicated, but if we go to this part, the currently passed law, it looks like that. So basically, without the AI, I don't think we could do law well. And if we could not do law well, it means that our economic growth will be just stopped by something like that. So we need to know what the law we should use. And hence, yeah, so much law. Hence, let's go to the court verdicts, because this is law in practice. This is the law, how it's used. So we have the biggest legal the court verdict provided by Ministry of Justice. This is the regional courts, so the normal courts. There is a Supreme Administrative Court, and this is the cases between the Polish taxpayers and the administration against the state. So if your revenue office says that you should pay more tax and you disagree with that, you will go to this court. And luckily, the most of the cases from the administrative courts are publicly available. For the normal courts, it's only about 2%. On this here, it's about 300,000 court verdicts. But each year, and this is from the many years, but each year it's about I think 1 million legal cases. So you see that this is not very big data set. But the other problem is that it's we don't know if it's randomly if it's a random sample or not. But it tends to get better with these courts. And there is a Supreme Court which is very important for our law. And the Supreme Court public most of the cases, but in this database there is only 60,000 cases made publicly, but all cases in the Supreme Court, it was almost 200,000 cases. So it's that, and there is also individual tax interpretations. So this is the four data sources, and this one is very user friendly. I would say that it was we did not spend months to get this data, but with those other courts, there are some problems, and usually if you try to download the data, you get this. So the one of the cases that we fought quite long, it was getting the data, and eventually we try to simulate human behavior, and this was the way to get this data. So we could start feeding our computers by the court ruling. The problem is that all those cases that it's put here are designed for human, not for computer. And if you ask for example, if you try to ask for more data to be computer readable, it's not so easy to get that. Usually you need to scrap it. And here, if we go to the court verdict, here we see that there are some certain sections. For example, description of the case. Then we have the legal there was a court. There was asking for one side for the court to say some ruling, and there is an introduction, and then we can see that there is certain logical parts, but those logical parts are not. Could be a paragraph, but usually you can either you need to merge few paragraphs into one part. Here you have the bullet points, or you need to split the paragraphs to get the logical part of the ruling, and this was kind of hard, and we create a system that you can ask the question, for example, what is the violation of law by bad interpretation or the bad usage. And if you, for example, go to the leading legal information providers, you will get the list of documents, but for example, you won't get the relevant part. So we try to, using the NLP methods, we try to retrieve for each ruling the part that is relevant for the legal question, and to able to filter that, and also to provide a feedback from the user to show the user the better fragments next time, to make the system learn. It's still learning, however, and if we click on the part, we end up in the place that it's in the context of it. Okay, so how we get it? Basically, when we build up a corpus which was about 50 gigabytes, in fact, it was when we get the interpretation, it is much bigger, and and we need to make quite intensive operation on it. First, we need to train the Polish language model. There are not many good language models for Polish language. And we trained a few ones, and we train it on our corpus. In fact, it's, I think, one of the largest corpora for the Polish language that we get, and it's about 4 times of the size of English Wikipedia. And it was quite computationally intensive to train the language model on it. And the second thing is that if we try to represent the logical fragment of the court verdicts as a vectors, we need to we need to transform the question to the set of fragments that we get from the court verdicts, and try to find the right one. And this is also not an easy task, and I will just explain it later on. First of all, if just some kind of reminder, I believe that most of people know the word 2-vec systems, but just to it basically try to produce the vector representation of the words based on the surrounding of the words. So, for example, word union, this is the text one of the European Union treaties have the completely different surrounding than economic, the word economic. But why I'm mentioning that? Basically, if we start to work with the legal texts in Polish, some words tend to have a different meaning than from the normal language. Of course, you need the background from the normal language, but if you go to the legal Polish language, you might get the different meaning. For example, there is a clause w szczególności, which usually mean in the language that we spoke every day, it would mean, okay, this is some kind of exception. But in the legal language, usually you get, oh, this is the most common case. So basically, this is there is a difference in that. So we can use vectors to get the meaning of the words, but we can also use the vectors to get the meaning of the phrases. There is another way. Another important thing, of course, the word-to-vec systems are from, it was from the beginning of the decade. But what is most important, and this extremely increased the accuracy of the system, is to use the context embeddings. So the models like BERT or the models like FLAIR have the better way to represent text than the word-to-vec systems. However, the problem with the context embedding is that if the judge makes the misspelling, and trust me, misspellings are very common in the Polish court verdicts, and there are quite many verdicts from year 3000. So, yeah, this is true. You can search it. Basically, you need the word-to-vecs usually handle the misspellings really well. The context embedding don't, and this is something. But most importantly, if we just dissect the court verdicts into logical parts, we can represent the meaning of each logical part as a vector. But if we take only the direction of the vector, then we can represent the meaning, and this works pretty well in this case, and give us the good accuracy. The problem is that if we think about the multi-dimensional sphere, we usually think about maybe some of us 4D, but the problem is that if we have the embedding that is much bigger, so this is the size that gives the reasonable that could describe the legal text quite well. And we created some experimental setup to see if it could be done, because it started as a research project a few months ago, in fact, almost a year ago. So we took the cases related to the corporate tax, which is SIT. It was about 4,000 paragraphs. But this is quite big sample of the court verdicts related to the corporate tax, and we vectorized it using 5 chosen types of word embeddings. And what we need to do is we have the vector describing the question. So we have some kind of a phrase. We try to describe it, and then we transform it into the representation of the vectors which were the same size but represent the logical parts of the court verdicts. And then we tried a few embeddings. The fast text which was created by Facebook, and this was a standard. I think it was the standard for a few years. The byte pair embedding, which looks on the n-grams, the parts of the word, the character embedding, FLAIR backward embedding, and our embedding that we created for this one, our model for the language. One thing about FLAIR is that, if you don't know, the FLAIR was constructed by Zalando to analyze the comments on the web page that clients left on the certain items, and this was holding a record for understanding the Polish language for some time, but this is one of many models. I did not put BERT here, and there was a reason for that. The BERT have the implementation. When we started the project, most of the implementation of BERT cannot handle the long text, and usually if we would like to have the logical argument that Kurt gave, it was quite a long text and exceeding the BERT limit. So Unfortunately, the BERT was not the best for us for this case. But what were the results? We took the question from the exam that it's many people consider to be quite complicated, which was tax advisor exam. So there is, and this is one of very few data sets that you have the question, and you have the court ruling that will answer the legal question. So unfortunately for the law, there are not many data sets like this. Data sets like this. So we took the first one was that of example that I show. It was regarding the client expenses for the advertisement, and second one it was about losses and from the related to the debts and selling those debts. And let's go. Fast texts, well, did not perform well, and this is the word-to-vec system like. The byte per embedding was good in one case, but in the other it was not good at all. Character embeddings was quite well, and the flare backward embeddings was kinda okay in one case, but in the other it was bad. So, and there was another embedding which tried to try to be as much invariant to misspelling as it's possible, but on the other hand, try to get the context out. We were still preparing the paper with this one. So, but let's look on the results. So basically here it was the question about the expenses for the advertisement, and character embeddings show the fragment which was from the good court verdict. This was and the flare also performed well, but look on the fragment. Basically, here it is. It looks only on the similar words, but this is not what this is not what the lawyer wants. Lawyer would like to have some legal argument backed by the law itself. So here we get of course here we get some information that we have the we need to go to this act of the parliament. This is the Ustawa o podatku dochodowym od osób prywatnych. So it's tax revenue for no, not a private, but for the companies. Sorry, but here we have much thorough legal argument. What is in which case this advertisement expenses would not fulfill this regulation. So basically, we could go to the good ruling, but we might not find the good part of the verdict. Secondly, there is about selling the debts, and can we? What about the expenses connected to this one? And here we have the same information. The byte pair that performed really well give you some text, which was the n-grams were similar. Character embeddings also, but here if you go to the embedding that performed the best, you get the legal argument, you get the legal essence. And this was the point in this project was to capture the legal essence. We need to train those models were equally prepared to handle the legal text, but only this one performed quite well and give the correct answer, which was those two were model answers from the book preparing for the tax exam. What about the stability of the embeddings? This was the other question. If we those questions were formulated basically in the legal jargon, and if we go to the stability of the embeddings, this is also from an unpublished article that will send hopefully in the next few months. We try to ask the questions that were reformulated more in the people. I don't know if IT guy would try to ask the legal question, and hence we got the information that our embedding was performing well. the byte per embedding was kind of okay, but the problem is that if we reformulate the language, we did not go to we did not ask it as it should be asked in the law, we might get different, one of the embeddings might perform better, one embedding could perform worse, but also with the byte per embeddings, the problem was that it was not the paragraphs that it should be, but something similar to the text. So basically, it's also the language of asking question was important here, and we try to get the embedding that language model that would be invariant to using the legal jargon or not, and to give the most relevant legal question. Okay, so one of the question that we try to so we started with we already put it live, this project, and it is tested by few legal companies right now, and this is an example of the system from the question what is the difference between the using the violating the law by bad usage or by bad interpretation. And what we will be trying to prepare quite soon, it's advanced filtering. For I hope that I could. Okay, I probably could not use the Blackboard for this one, but to add the filtering and visual analytics, if you recall the graphs that I show at the very beginning, we can do the same for the court. There is something like line of the court ruling, and there is and if we get the meaning of the court verdicts, if we dissect the court ruling on the legal arguments, we could follow the thought of the court. For example, if we have two cases from the VAT tax, we can compare the two cases and see if the arguments are following, see what arguments are different, or we can just take all the court's cases from the one court that is important for our clients and compare the arguments, see what arguments were common in all cases, which were different, and try to find the most similar case based on the state of the, I don't know, it's in Polish it's stan faktyczny, which is the initial legal state of the case. And we can basically, if we have the language model like that, we can compare the important fragments between the rulings. The other thing, if we can do that, we can go to the analysis of the court lines of the court ruling, and they are not. We do not use the common law, so the court rulings are not synchronized between courts, and sometimes you get for the same case you get the different verdict depending on the court and depending on the judge. So basically, we try to, by creating a good language model, we try to create the way of analyzing the texts, court ruling like that. The other funny thing about the Polish law that when we try to analyze the text, we find out that about 10% of the Polish court verdicts are copy paste. It just, but what?
Is it a plagiarism?
I think it not in the legal sense. Well, except one ruling when the mistakes in the commas and the misspellings were exactly the same in the both court verdicts, and this was a problem with. I think it ended in the disciplinary hearing for the one of the judges. I think we know which verdict was first, but basically it's kind of good news, because then on top of that, if we know that there is a copy paste, then we can more easily follow the court ruling, and then we can get can make the other stuff that is interesting. So predictive analytics. So we see what are the arguments and what would be the outcome. We could predict the outcome of it. So basically, and this is the stuff. This is the holy grail that we would like to get to predict the outcome of the cases in Polish courts, which might not be very easy, but we think from what we get from our R&D, I think we are on the good track. And so basically, this is the cases that we the visual analytics will be adding very soon. So I was hoping that I could just show the graphs to you, but it probably will be in the next week. But information retrieval. What is important about information retrieval from the Polish court verdicts? Basically, we can go through the document, and we can just easily get the information. Check if one argument were used in the how many cases connected to the value-added tax, which is kind of important for the Polish companies. So this is about the plagiarism. We just by accident we note, but that from this vector representation we can get very easy we can just get how many copy pastes were in the cases, and in fact it could be used even for if the meaning is corresponding, how many of the arguments were used in the same cases. Okay, so this is what we are trying to do, and the key for this one, all of that was very trained model on the Polish verdicts, and this is crucial for getting the information from legal text. And the one thing that we worried a lot is that the Polish language could be very unfriendly for the NLP. We find that it's not, but it requires much more computational power than other languages. And the system that we created could be extended to any type of legal documents, and we can do the search for the legal articles. And this is already in tests in few law firms in Poland. One of the cases that we would like to solve using this NLP system was that the nightmare for the lawyers is that if you, usually in legal text, you have certain keywords that are used. So you usually use the keyword for, I know, stłuczka, wypadek, or something like that. The problem is that if some judge will not use the keyword, then it would be very hard to find this document. And we try to deliver the searching by meaning, not by keywords, and to them, and to make their life easier. So thank you very much for your attention, and I will be happy to answer the questions.